Hello, our group number one. Our team worked on this project to address the real-world problems of urban sewage pollution and backflow problems caused by sudden increases in sewage inflow. Currently, sewage from homes contains not only solid oils and organic matter, but also microcontaminants. Central sewage treatment plants have variable treatment efficacy and high maintenance costs, making it difficult to reliably remove all contaminants. Furthermore, heavy rains can cause rapid increases in water pressure. Therefore, we believe that we could alleviate these problems by creating a device that simultaneously reduces contaminants at the domestic sewage stage and maintains a constant water flow. To achieve this goal, we designed a flap system prototype.
We designed the prototype using three scientific principles. The first is physics. A flap is installed at the sewer pipe inlet. It opens stably when the water pressure, torque, and spring torque are balanced. This prevents backflow during heavy rains and maintains a constant flow rate. The second is chemistry. Through actual experiments, we found that alum, a coagulant, was most effective for solids, detergents for oils, and hydrogen peroxide or oxidizing agent for organics. This utilized chemical mechanisms tailored to the characteristics of each contaminant. The third approach is biological. We created a structure that utilizes a biofilm and activated sludge layer to allow microorganisms to decompose BOD and nitrogen, while also removing some phosphorus and trace contaminants. By connecting these three layers into a single prototype, we created a system that simultaneously removes contaminants and regulates flow.
Prototype consists of three layers connected in sequence. The top layer features a flap device that is normally closed and opens to regulate flow and water flows. Below this is a chemical treatment layer designed to rapidly neutralize or precipitate solids, oil, and organics using alum detergent and hydrogen peroxide, respectively. The final layer is a biological tank where microorganisms decompose organics and nitrogen based on a retention time we set for 16 hours. These three layers are structured as a single integrated flow system capable of immediately and partially removing household contaminants, stabilizing water flow, and biologically treating residual contaminants.
First, in the chemistry experiment, solid oil and organic contaminated water were prepared and three household chemicals were added to compare the results. Compared to the control group, alum, detergent, and hydrogen peroxide showed the greatest visual and chemical responses and were selected. Next, in the biology design, the sewage inflow was assumed to be approximately 20 meters per day, and the reactor retention time was set to 16 hours. Using the first order reaction equation, BOD, ammonia, phosphorus, and trace contaminants were calculated and the removal rate estimated. Finally, in the physics design, it was confirmed that at a rainfall rate of 95 mm, the water pressure torque equaled the spring torque, fully opening the flap. This was followed by a verification that the structural stability was maintained even at a rainfall rate of 100 mm as the water volume increased. The graph also same.
The chemistry results showed that alum had the strongest effect on sedimentation of solid. The detergent precipitate oil and hydrogen peroxide oxidized and coagulated organic matters. The biology results showed that BOD decreased from 2.4 kilograms to 0.044 kilograms per day, and ammonia from 0.6 kilograms to 0.17 kilograms. While phosphorus and micropollutants were somewhat reduced, additional processing was required. The physics results confirmed that the flap reliably opened and locked at 95 millimeters per hour rainfall, preventing overflow. Furthermore, the flap's structural stability was maintained even under 100 millimeters per hour.
We realized that a single disciplinary solution cannot solve urban wastewater problems. Physics regulates flows to stabilize the overall system. Chemistry handles phosphorus and trace pollutants that cannot be removed biologically. And biology decomposes organic matters and nitrogen, ultimately purifying the water. Only when these three disciplines work simultaneously? Can they complement each other's limitation and address the complex nature of wastewater problem? However, we realized that our solution had shortcomings. The feedback taught us that application require most consideration of practical factors, such as chemical dosage control, sludge treatment, and filter cleanness. We realized that our prototype didn't reflect reality well and felt that further development was needed. Thank you for listening.